Okay, here's week 21, part 2. We're talking about a pendulum. And so it's attached to the ceiling. This is the bob, this is the light string, and of course it swings back and forth. So, you wish to, this is sort of an experimental design type question. You wish to experimentally determine the frequency of the swinging pendulum. So, when we check the box, if we did this in class, determine the frequency. So you know that the time it takes to swing back and forth once, meaning from here to here, that is the period of oscillation, and period and frequency are reciprocals. So the equipment we would need is simply stopwatch. So you could and then part B is we're going to describe how we would do that. So for part B, we're describing the what measurements we would take, and then how from those measurements we would actually determine the frequency. So I said something like, I would let the pendulum swing back and forth 10 times. I would then divide this time by 10 to obtain the period of oscillation, and using frequency equals 1 over t, I would then divide 1 by the period of oscillation to determine the frequency. So here I'm putting the formula into words and sort of describing the process of just solving the simple equation. But this right here, we did this in class, and a lot of people were just timing one oscillation, but you really do reduce your error or uncertainty if you let it swing back and forth more times and then divide. So you effectively, this effectively divides our uncertainty in the starting and stopping of the stopwatch by 10, which would be a good thing. So, C. You next wish to discover what parameters of the pendulum affect its frequency. Parameters meaning variables, or things that we can control. State one parameter that could be varied. Describe how you would conduct the experiment and indicate how you would analyze the data to show whether there is a dependence. So, the things about the pendulum that we can change, if we look at this and kind of think about it, like right here, okay, we could change the length of the pendulum, and we could also change the mass of the pendulum. So we could have something that was like that, okay, same length, different mass, or we could have something like this, same mass, different length. You know by this point, hopefully, that these, same length, different mass, are going to have the same period of oscillation, so same frequency. The long one, however, is going to swing back and forth slower, meaning a longer period of oscillation and a shorter frequency or smaller frequency. So what I wrote, I wrote two things. So one is you could change the mass, and you could measure the time it takes to swing back and forth for different masses, and what you would expect to see is that there's no change in the period of oscillation when we vary the mass. But in taking this exam, you'd probably want to say, I would change the length, because you know that that is the parameter that actually affects the period of oscillation. So you could say something like, I would vary the length, so create 5 different pendulums of different lengths with the same mass, right? So you're isolating one specific variable that you're looking at, and I would measure the time, just like right up here, measure the time, or repeat this procedure, you could say. Time it takes to swing back and forth once. Let's see what's going on here. D, after swinging for a long time, and we know this from reality, the pendulum eventually comes to rest. Assume that the room is perfectly thermally insulated. So, neglecting friction, the pendulum sits there and swings forever, but we know that it will eventually come to rest, so that is simply due to friction. And the friction that this experiences isn't a whole lot, okay, but there's friction in the string, just having to bend the string, and then basically when it swings back and forth, it's experiencing some air resistance, and it's moving slowly, so it's not a lot of air resistance, but there is some. So this situation, assume the room is perfectly thermally insulated, no heat can escape. How will the temperature of the room change when the pendulum comes to rest? So is a very slight, but the temperature of the room would increase. The kinetic energy, okay, so potential, kinetic, potential, kinetic, potential, kinetic. So the mechanical energy of the pendulum goes from something to zero, and that energy is lost due to heat. So, where's my answer? So, kinetic energy or mechanical energy is lost due to heat. Therefore, the air molecules are actually moving slightly faster in the room, and the temperature would increase. I doubt that would be immeasurable, even with a super sensitive apparatus in a laboratory or whatever. And then part E, this is actually not on our AP test. This is from an older version where there were different topics, but another pendulum using a thin light metal rod. So a rigid pendulum, so this is a metal rod, and it's thin and light, but if the temperature of the room was to increase significantly, so what we used to learn in AP Physics is that it's called thermal expansion. So a piece of metal will actually increase in length as it gets hotter. So this question is saying that the length of the pendulum increases, therefore the period of oscillation would increase if the length increased. And remember our equation for period of oscillation of a pendulum, 2 pi L over G. So if the length increases, the period of oscillation also increases. Thank you for listening.